section 7.1 is an introduction to hypothesis testing. So we have something called a hypothesis test here, and it says a hypothesis test is a process that uses sample statistics like means, proportions, and variances to test a claim about the value of a corresponding population parameter. For an example, it says a car manufacturer advertises that its new hybrid car has a mean mileage of 50 miles per gallon. To test this claim, a sample would be taken, and using what we've learned from previous sections, we can determine if the sample mean differs enough from the advertised mean, and if so, we conclude that the advertisement is false. So, first thing we have here is stating a hypothesis. It says a statement about a population parameter is called a statistical hypothesis. There's always going to be two types of hypotheses. The first one is called the null hypothesis, and the complement of the null hypothesis is the alternate hypothesis. Either hypothesis may represent the claim. So, a null hypothesis, this is the symbol that we use for null hypothesis. It's an H with a little zero at the bottom, is a statistical hypothesis that contains a statement of equality. Okay, so there has to be something about a statement of equality in there, such as either less than or equal to, greater than or equal to, or simply equal to. The alternate hypothesis, HA, which we have right here, HA for alternate, is the complement of the null hypothesis. It must be true if H0 is always false and always contains a statement of strict inequality, meaning either greater than, less than, or not equal to. H0 is read as H sub 0 or H naught, while HA is read H sub A. A lot of times, guys, I just say HO and HA. I don't really do the whole sub, and I know it's a 0, but I always say HO. Let's see. Some possible hypotheses regarding claims made about a mean mu are shown below. Regardless of which you use, you always assume that mu is equal to k, an example of the sampling distribution on the basis of assumption. Okay, so we have some examples here, and I want you to notice the null hypothesis always has some kind of equality, whether it's less than or equal to, greater than or equal to, or simply equal to. Okay? So remember what we said the alternate is. The alternate hypothesis is going to be the complement. So if my null hypothesis is saying that mu is smaller than or equal to k, think about what the complement, what's the opposite of saying something is smaller than or equal to? Well, that it's bigger than. Think of, it says here mu is greater than or equal to k. Think of the complement of that. What's the opposite of saying something is greater than or equal to? Well, it's smaller than. And if something is saying something is equal to k, mu is equal to k, what is the complement of that? Well, it's not equal to k. So for the first couple of problems here, we're going to write the claim as a mathematical statement. We're going to state the null and the alternate hypothesis and identify which represents the claim. Okay, so reading the first problem here, problem number 1, it says a water faucet manufacturer announces the mean flow rate of a certain type of faucet is less than 2.5 gallons a minute. Okay, so remember, the symbol that we use for mean is that funny looking U, right, mu, and it says is less than 2.5 gallons per minute, less than 2.5 gallons per minute. This here happens to be my claim, okay? So I want to think about if this is my mu is less than 2.5 gallons a minute, okay? Then this is going to be my HA, okay? This is going to be my alternate because the null hypothesis has to have some kind of an equal in there. If you notice these here at the top, they all have some kind of an equal. So I want you to look at, say, this second one right here in the middle. Let me box it in green. So if my alternate is saying that it's less than Then my null hypothesis is going to say, well, it's bigger than or equal to 2.5 gallons per minute, okay? Now take a look at number 2. It says, a cereal company advertises the mean weight of its contents of its 20-ounce size cereal is actually more than 20 ounces. Okay, so what are they saying? That the mean is actually more than 20, so greater than 20 ounces. This is my claim, okay? Notice there's no equal to here. This is going to be my alternate hypothesis. So my null hypothesis, what's the opposite of saying something is greater than? Then it would be saying something is smaller than or equal to, okay? All right, I'm going to scroll down to the next one. It says the university publicizes that the proportion of its students who graduate in 4 years is 82%. Okay, so we're not talking about means, we're talking about proportions. So P is 0.82. This here is our claim. Okay, because there's an equal to here, this is my null hypothesis. This is my HO because of that equal to part. So then my alternate hypothesis, what's the opposite of saying something is equal to? Saying that it's not equal to, okay? So the one thing I want to mention is that in these particular problems, the claim is going to be the statement that's being made. And that claim can either be my alternate hypothesis or that may be my null hypothesis, okay? The first thing I'm going to do, I want you to notice in every one of these problems, the first thing we did is we wrote down our claim. That was the first part we wrote down. And then once we got our claim, we were trying to figure out, was that claim my alternate or was that claim my null? And the way I look at it is I look at what symbol I wrote down, okay? So if you notice here, I have strict inequalities. That's telling me that that is my alternate, because the equal to part is always going to be the null, the one that has the HO. In this particular problem, because we started off with our equal to part, that was my null. And so the second one was my alternate, okay? So the one thing I want to mention, I'm going to write this over on the side, the HO is always going to have either an equal, a less than or equal, or greater than or equal, okay? And then my HA will either be not equal, either less than, or greater than, okay? That's how I know which one I'm going to do. Oops, the other way. Okay, take a look at number 4. A realtor publicizes that the proportion of homeowners who feel their house is too small for their family is more than 24%. So we're talking about proportions, so I'm going to use P, and that proportion is more than 0.24. This here is my claim. Because there is no equal to, that's my alternate. So then my null is the opposite, is the opposite of greater than 24, which would be less than or equal to 0.24. Okay. A school publicizes the proportion of its students who are involved in at least one extracurricular activity is 61%. Again, I'm talking about proportions, so I'm going to use P. Is means equals 0.61. Again, remember what I said? I'm going to write down my claim because that's the first piece of information that I know. Now that claim happens to be my null hypothesis because of the equal to part. Okay? So then my alternate is going to say, well, what's the opposite of equal? Not equal to 0.61. Okay? All right. So now we have something called types of errors and levels of significance. Regarding which hypothesis is a claim, you will always begin a hypothesis test by assuming the null hypothesis is true. Okay? We're going to always assume the null hypothesis is true. A sample is then selected, and when we perform the test, you're going to make one of two decisions. We're either going to reject the null hypothesis, or we're going to fail to reject the null hypothesis. Okay? Keep in mind that you're only dealing with a sample, so you must accept that your decision could be incorrect. And we have two types of errors here. A type 1 error says if the null hypothesis is rejected when it's actually true, and a type 2 error occurs if the null hypothesis is not rejected when it's actually false. And so we have our types of errors right here. Okay. So I'm going to sort of explain that right here in this part. Let me see if I can. There we go. It looks a little bit better now. I can see a little bit better. So it says hypothesis testing is sometimes compared to the legal system that we use in the United States. So under the system, these steps are used. Number one, a carefully worded accusation is written. Okay, so they're going to say, number one, Omar, you robbed the bank. Okay. And so let's take a look at number two. The defendant is assumed innocent. So the assumption is I'm innocent until I'm proven guilty. The burden of proof relies with the prosecution. If the evidence is not strong enough, then there is no conviction. A not guilty verdict does not prove that I was innocent, right? So think about what this means. This means that suppose I actually robbed the bank, okay? If I was found not guilty, they didn't prove that I was innocent. They just didn't have enough evidence to prove that I was guilty. Or even if I didn't rob the bank and they came back with the not guilty, they didn't prove my innocence. They just were not able to prove that I was guilty. Number three says the evidence needs to be conclusive beyond a reasonable doubt. The system assumes that more harm is done by convicting the innocent. Convicting the innocent would be a type 1 error, okay? Then by not convicting the guilty, which would be a type 2 error, okay? So here is our type 2 error and here's our type 1 error. So type 1 error is I was found guilty, but I was really innocent. This is a type 1 error. That is a much bigger error than if I was actually guilty, but the verdict found me not guilty, okay? So the objective here, according, like using our legal system, is we don't want to send innocent people to prison. We would much rather have somebody who is actually guilty maybe get off than by putting innocent people in prison, okay? So we're going to sort of explain what that means here. We're going to explain that concept using this example here. It says a company specializing in parachute assembly states that its main parachute failure rate is not more than 1%. Okay. So if it says that the failure rate is not more than 1%, then that means that the rate, call it R, is going to be less than or equal to 0.1. Okay, this is what the claim is, right? They're saying that their rate is less than 0.1. Okay, this is my null hypothesis. So then my alternate hypothesis is going to say the rate is actually greater than 0.1. Okay, and it says now we're going to perform a hypothesis test to determine whether the company's claim is false. Identify the null and the alternate hypothesis and label the claim. Write the possible 1 and type 2 errors, which is more serious. Okay, so we're talking about parachutes here, right? So suppose we decide we're going to go skydiving. They're saying that the failure rate is less than 1%, okay? And we're going to decide whether or not that's true or not. So I'm going to come back. I'm just going to pull up this piece right here. I was working on it earlier. This is just from our notes. So type 1 error says we're going to reject the null when it's actually true. So let's see what that means. So we're going to assume that this is actually true, that the failure rate is actually less than 1%, but we're going to reject that. Okay, so failure rate for parachutes is less than 1%, but we reject it. Okay? Now, let's look at a type 2 error. So a type 2 error is the claim is actually false, but we don't reject it. Okay? So let me come back here. So the claim is false, but we do not reject it. Okay? Do not reject the null. Okay? So let's explain, let's see if we can understand what that means. We're all going to go skydiving, okay? And don't get nervous because this is just an example. So suppose the failure rate is really as less than 1%, but we reject it. So we say, you know what? I'm not sure that the failure rate on these parachutes is less than 1%. I'm not going to go skydiving because, you know, maybe it's going to be too dangerous. Okay? That's would be a type 1 error. Now, a type 2 error the claim is false. So what does that mean? That the failure rate is actually greater than 1%. But we don't reject it. We don't think that that their claim was actually incorrect. So we decide to go skydiving, even though the failure rate on those parachutes is bigger than 1%. How much bigger? I don't know. Maybe it's 2%, maybe it's 1.05%, or maybe it's 80%, right? 80%. Think about what that means. Out of 5 of us are going to go parachuting, 4 of us may not be able to go parachuting again, right? So this is the one that's the more serious because they can have major consequences, right? Okay. So the next part here says, so how do we know whether to reject the null hypothesis? This depends on whether you get an unusual sample statistic from the sampling distribution. We have seen unusual being defined as a probability of less than 0.05, and it says there's always a possibility that we're going to reject the null hypothesis. It's actually true. To decrease this probability, we can lower the level of significance. So let's see what it says here. It says, in a hypothesis test, the level of significance is your maximum allowed probability of making a type 1 error, as denoted by alpha. And the probability of making a type 2 error is going to be denoted by beta. So we have something called statistical tests and p-values. So it says, after stating null and alternate hypothesis, specifying the level of significance, obtain a random sample and compute or calculate the sample statistic, x bar, p hat. We're not going to be doing the s squared business here. Corresponding to the parameter in the null hypothesis. The sample statistic is called a test statistic. With the assumption that the null hypothesis is true, the test statistic is converted to a standardized test statistic, such as a z or a t. We're not going to be using chi-squared. That's what that one would be, which will be used in making the decision about the null hypothesis. Determine if the probability of obtaining the standard test statistic is less than the level of significance. So it says, if the null hypothesis is true, then a p-value or a probability value of the hypothesis test is the probability of obtaining the sample statistic with a value as extreme or more extreme than the one determined from the sample data. Okie dokie. So now we have 3 types of hypothesis tests. We have left-tailed, right-tailed, and two-tailed. The type depends on the region indicated by the alternate hypothesis, okay? So I'm going to be looking at my alternate hypothesis to determine whether or not we have a left-tailed, right-tailed, or two-tailed, okay? So I want you to look at something here. Left-tailed test. It says the alternate hypothesis contains the less than inequality symbol. All I'm doing here, y'all, is I'm looking at my HA, and I'm going to look at the direction of the inequality. If it's pointing to the left, it's a left-tailed test, and my p-value is going to be the area underneath the curve right there, to the left of that test statistic. Okay. Now, what happens if we have a right-tailed test? Then my HA should have the greater than inequality. Notice it's pointing to the right, and look where my p-value is going to be. My p-value is going to be the area over here to the right. Okay. Now, what about a two-tailed test? If the alternate hypothesis, my HA, has the not inequality, then each tail has an area of half of that p-value. Okay. So half of that p-value will be here, and half of that p-value will be over there. Okay. Two-tailed because there are two parts. Why? Because when something is not equal to, that means it's either less than or greater than. Okay. Now it says for each claim, state the null and the alternate, then determine whether the hypothesis test is a left-tailed, right-tailed, or two-tailed test. Sketch a normal sampling distribution and shade the area for the p-value. Okay, so we've done parts of these problems already before. So this first part is going to be repetition of what we did earlier. Look what it says. A water faucet manufacturer announces that the mean flow rate, so that's my symbol for mean, right, is less than 2.5 gallons per minute. Remember, this is my claim. That's the first thing I'm going to write down. Okay, then I'm going to look at this part here and I'm going to say, look, this does not have an equal to part, so this has to be my alternate because my null will have an equal to part. So what's the opposite of saying something is less than? Saying something is bigger than or equal to. Okay? All right. So let's take a look. We're gonna get to the left tail, right tail business. So we're gonna, for each claim, we're gonna state the HO and the HA. We've done that already. We decided which one was our claim. Then we're going to determine whether the hypothesis test is a left tail, right tail, or two tail test. The way we find that out is we have to look at our alternate. Look at the direction of the inequality sign. It's going to the left. So that means I'm looking for this little p-value, this little probability over here. Okay, this is going to be a left-tailed test. We're going to figure out actually how to do some of these problems in the next section, guys. We're just breaking these parts down into pieces, okay? And that's all we needed to do for that first problem, okay? Let's take a look at number 8. It says, a cereal company advertises that the mean weight of its contents of a 20-ounce size cereal is more than 20 ounces. Okay, so I'm dealing with mean again. So mu is greater than 20 ounces. Remember, the first thing I'm always writing down is my claim. Okay. So again, this here is going to be my HA because I don't have an equal to. So then my HO is going to be mu is less than or equal to 20 ounces. Okay. So again, we have our HA, we have our HO. We've decided that our HA is my claim. Now we're going to determine, is this a left tail, right tail, or a two tail test? So I'm going to look at the direction of my inequality sign on my alternate, always on my alternate. It is greater than. So we're looking for this little piece of area over here. That's going to be my p-value, okay? And this is telling me that this is a right-tailed test. Right? I'm going to do the same thing for number 9. A university publicizes that the proportion of its students who graduate in 4 years is 82%. Okay, so the proportion is, 82. This again, y'all, is my claim, right? And this happens to be my null hypothesis because there's an equal sign there. So then my alternate hypothesis is going to say this is not equal to, 0.82. Okay, because the opposite of saying something is equal to is going to say something is not equal to. So now, because I'm always going to look at my HA to determine whether I have a left tail, right tail, or two-tail test, and I see it's not equal to, remember the area and under each of these curves is going to be half of P. Okay, and this here is a two-tailed test. Okay. All right. So now the next part here says making and interpreting a decision. To conclude the hypothesis test, make a decision to reject or fail to reject the null hypothesis. The decision depends on your p-value and your level of significance. Okay, so it says right here, here's my decision rule based on my p-value. Okay, if p is less than alpha, we're going to reject the null hypothesis. If p is greater than alpha, then we're going to fail to reject the hypothesis. Okay, so again, notice what it says here. It says, it says failure to reject the null hypothesis does not mean that you've accepted as the null hypothesis is true. Instead, there's just not an evidence to reject it. If the claim is the null hypothesis, it's either rejected or not rejected. If the claim is the alternate hypothesis, it is either supported or not supported. Okay? So we're going to be using this little chart that I have right here to kind of answer our questions. Okay? So give me one quick second. All right. So let's go ahead and see if we can figure out how to do these problems here. It says basically, if you reject the null hypothesis, you're supporting the alternate. If you fail to reject the null, but you cannot support the alternate. It says determine whether the claim represents the null hypothesis or the alternate hypothesis. How should you interpret your decision if you reject the null or if you fail to reject the null? Okay, so let's see if we can read through this problem here and figure it out. It says a scientist claims that the mean incubation period for swan eggs is less than 40 days. Okay, so they're saying that the mean is less than 40 days. Okay, this is our claim. Okay, now guys, notice this claim here does not have an equal to. This is going to be my, oops, let me get my pen. Oh, come on, don't freeze up on me. Sorry, guys. This is going to be my alternate, right? So my null hypothesis is going to say that the mean is greater than or equal to 40 days. Okay, so a couple things I want to point out here. Our claim happens to be the alternate, okay? Now, I'm going to pull up, I'm going to come back, I'm going to look at this piece right here, but so I don't have to keep moving it back and forth, I have it right here, okay? And the only thing I'm going to do, let me do this, let me see if I can make the point a little smaller, there we go. Okay, so let's do something like this, and maybe something like this, just so that it's a little bit more separate, okay? So, first thing we're going to do is we're going to say, what happens if we reject the null? Okay, so part number one. What happens if we reject the null hypothesis? Notice which one is my claim. My claim is the alternate. So when I come back here, my claim is the alternate, right? And we're rejecting it. So this is what I'm going to write down. I'm just going to say there's enough evidence to support the claim. So right here, I'm going to say there is enough evidence to support the claim. Okay. Now, the second part says, what happens if we fail to reject? Number two, if we fail to reject the null. Remember, my claim is the alternate. My claim is the alternate. If I fail to reject, then I'm going to say there is not enough evidence to support the claim. Evidence to support the claim. And all I'm doing here, guys, is I'm just trying to figure out which, in this little table here, in this table right here, I'll leave the pen here. But in this table right here, I'm just trying to figure out which part I'm going to use, okay? And I'm going to pick one of these little 4 squares. And every one of my answers, it's going to be one of those little 4 squares, okay? So let's take a look at number 11. Number 11 says, a university publicizes the proportion of its students who graduate in 4 years is 82%. Okay, we've done this part before. The proportion is 0.82. Here is my claim. This is my null. My alternate is going to say P is not equal to 0.82. Okay, so first thing I want to mention, my claim happens to be my null, okay? And we're going to go through those 2 case scenarios. One of them, we're going to reject the null, and the second one, we're not going to reject the null. Okay, so case number 1. What happens if we reject the null hypothesis? Remember, the null happens to be my claim, okay? So the claim is my null, and we're rejecting it. We're going to say there is enough evidence to reject the claim. There is enough evidence to reject the claim. Okay? Now there's the second part, right? Second part is what happens if we fail to reject. Okay? So again, I'm just going to scooch back here. I want to remind ourselves that my claim is my null. Okay? My claim is my null, and we're going to fail to reject it. So my claim is my null, and we're going to fail to reject it. I'm going to say there is not enough evidence to reject the claim. There is not enough evidence to reject the claim. Okay? And we have a number 12. Okay? Number 12 says, Consumer Report states that the mean stopping distance on a dry surface for a Honda Civic is less than 136 feet. They're saying the mean, less than 136 feet. Here is my claim. This happens to be my alternate hypothesis because my null hypothesis will always have the greater than or equal to. Okay? Okay, so first thing I want to mention, my claim happens to be my alternate hypothesis, okay? But the one we're going to reject or fail to reject is always going to be the null, okay? And the reason why I want to mention that here is, let me get my eraser, let me just kind of clean up some of this mess, and I'll do it again just so we can see what's happening. But, whoa, I didn't want to do that, sorry guys. Let me come back to where we was. Where was we? Here we go. This is where we were. Okay. So here's my chart, right? And I want you to notice, here we go. Oops. There we go. There we go. There we go. Okay, the two options are either to reject the null or to fail to reject the null, okay? So those are the ones that I'm always going to reject or not reject, okay? So let me come back, come back to my original problem here. So our claim happens to be our alternate. So we're going to have two case scenarios. Number one, we're going to reject the null, okay? Our claim is the alternate. So when I come back here, my claim is the alternate, and if we're going to reject it, we're going to say there is enough evidence to support the claim. Is enough evidence to support the claim. Sorry about my handwriting, guys. It's pretty messy. Okay, number two. If one was to reject it, number two is going to be fail to reject it. Fail to reject the null, okay? So I'm going to come back here, fail to reject the null. We're now going to say there is not enough evidence to support the claim. There is not enough evidence to support the claim. There is not enough evidence to support the claim. To support the claim. And that right there is 7.1. In 7.2, we're going to actually get to how do we do these tests, okay? 7.1 is just breaking these parts down.